Welcome back to the last section in Chapter 2. This is Section 9, all about absolute value functions. So we're going to see what they look like, and then we're going to use those transformations that we saw a couple sections ago, and we're going to use it to transform the parent absolute value function into any of them that we want. This case, it's a little bit more entertaining than lines because there's actually pieces of an absolute value function. For instance, this blue graph that's been up here this whole time is actually an absolute value function. I put that because a line is boring. It would have just been a random line going across the screen. So here, it does something. And if I moved it, we could tell that I moved it. So that's a lot more exciting than an actual line. So let's look at our learning target for today. I can graph and transform absolute value functions. And so let's look at an absolute value function. Being that we don't know how to graph it, other than I just showed you that, hey, it makes that little shape there. If we don't know how to graph something, make a table. That goes for anything. If you don't know how to graph it, make a table of values. Plug in points and see what the shape looks like. For us, let's start with the parent function. F of x equals the absolute value of x. So make a table. We have x values, the absolute value of x values. For x values, let's just use 3, 2, 1, 0, negative 1, negative 2, negative 3. Then absolute value just makes it positive. If it's positive, it stays positive. If it's negative, it becomes positive. And so these values look very similar to the previous values that we were looking at. Now to graph it. We get a graph. We can plot some points. So there we go. And notice it has this shape. We plotted our points, connect the dots. It's straight lines. We're looking at linear absolute value functions. And so we can connect the dots that way and that way, and it makes this shape. It's a V. Absolute value functions make a V shape in the graph. I really wish that there was a way to remember that absolute value functions make a V shape in the graph, but I don't know, people always forget that. They make a straight line. So if you can figure out a way to remember that absolute value functions make a V shape, that would be super, and I'd love to hear about it. So that's the parent function. We can do some transformations to this. But before we get that, the absolute value function has this point right here. The absolute value function that makes a V shape, at the very point of that V is the vertex. And that vertex for the parent function is at 0, 0, at the origin. So we can move that. We can do transformations on that and translate it. We can move it h units over to the right and k units up. Just like when we were doing transformations, we moved it over h and up k. Those are standard variables, and we'll see that consistently. So we want f of x minus h, because remember everything horizontal is going to be backwards, plus k. This means we're going to take the function, and we're going to replace x with x minus h. So the x minus h will be inside the absolute value, and the plus k will be on the outside. So g of x equals the absolute value of x minus h plus k is an absolute value function with the vertex at h, comma k. And then we can do a vertical stretch or compression to change the slope. And technically we're going to do the vertical stretch or compression before we move it, but we're going to stretch it vertically by a units. So the a just goes right in front of the absolute value. That is going to be the slope of the right side. It's going to be this slope right here. Notice right now it's 1. This has a slope of 1. The slope of the other side is negative a. And so the slope is negative 1. And so now we only use vertical. We're not doing horizontal. Later on we'll see what happens horizontally and we change it to a vertical deal. And we also don't have reflections, because reflection, we would just make a negative. If a was a negative 2, the slope on the right-hand side would be negative 2, and the slope on the left-hand side would be negative that, which would be positive 2. So if a is negative, that'll get us the reflection to make it an upside down V. And so, if we want to write an equation from a graph, here's a graph. We want to write the equation. We need two things. We need the vertex, and we need the slope of the right-hand side. So our vertex here is at 1, 3, and the slope, let's see, we have this point, so to go over 1, we go down 2 over 1. So our slope, down 2 over 1, our slope is -2 for the right slope, not the left-hand slope, the right slope. And so when we plug it in, we'll have an absolute value of x minus 1, and then plus 3, then -2 in front of the absolute value. Y equals -2 times the absolute value of x minus 1 plus 3. So once we have these things, we just need to plug it into the equation. We can also graph from an equation. If we have an equation, y equals 1/2 x plus 2 minus 1, we can graph. We know the vertex is going to be -2, -1, so we can put a point. And then we're going to go, the slope is up 1 over 2. Up 1 over 2. Up 1 over 2. I'm out. On this side, we'd go up 1, backwards 2. But that takes me off my graph. So instead of going up 1, backwards 2, I'm going to go up 1/2, backwards 1. And then we can connect the dots to make that V shape. Notice here we had a vertical compression. It flattened the V out a bit. Here we had a vertical stretch. It angled it a bit more. It doesn't have that slope of 1 that would take it right down here. And now we can graph another one from an equation. And here's where I put through the horizontal stretch and compression in, because we don't use that. When we look at this, what is the vertex here? If you said -6, -1, that is not correct. No, it's not +6 either. It's not 6. Our equation, we have the absolute value of x minus h, not 2x minus h, x minus h. If you have something like this, where there's a number in front of the x, you need to factor that out. So it's 2 times x plus 3. And then this multiplication can actually come to the outside of your absolute value. And it will become positive. In this case, it already was positive. If we factor out a -2 because we had a negative x inside, it would become positive when it comes to the outside of the absolute value. So this can become 2 times the absolute value of x plus 3 minus 1. We can graph this. The vertex now, -3, -1. See, it's not the 6, it's a -3. So we have vertex, and then the right slope is 2. We can plot the vertex, and then up 2 over 1, up 2 over 1, up 2 over 1, to get a graph that looks like this, if you're following along in the home game. And so that's absolute value functions. It's a V shape. We have our formula that has a vertex and the right-hand slope in it. We'll be going 2 graphs from the equation, 2 equations from the graphs, and even a little bit of transformations, which is built into the formula as it is. And so this is really just transformations with the V for the absolute value. So that is the end of the chapter. I'll see you again next chapter. Until then, happy mathing.